and see if I can close the door to keep from bothering people up and down the hall. Okay. We are recording now. Let me get the PowerPoint started. And we're still in Chapter 1, unfortunately, Functions in the Graph, 1.5, Analyzing the Graphs of Functions. We're almost through with this. We've got two examples of one sort of small topic to do, and we'll be through. Any questions from anything so far? Oh, and here's the other thing I meant to say. Yesterday, got an email that we're supposed to put in for no-shows, and that really doesn't affect any of you because all of you have been showing, okay? But there was only one student in this class. In fact, I think the only student in all my classes, one student, was a no-show. But in doing that, that shows only the students they count as registered. And there were a couple of you that have been coming just about every day, and it wasn't show you as registered. So I've talked with one. There's one other I need to talk with. I need to Patel. Okay, he's here. So on your way out, if you have any doubt about whether you are on the roll or not, please stop by and see me, and I'll let you know. Okay. So. But everybody else is clear. I just don't want the end of the term to get here and they say, oh, no, you never registered for the class. Because if your name's not on the official roll, I can't give you a grade. Okay? I can't. You're not on there. So please, let's get this straightened out. Probably a administrative thing. Someone forgot to enter a key or something like that, and it didn't show up. Okay. Any questions? All right, we're on page 54, section 1.5. We have done example 6, but example 7 is on the slide set, so I need to set my pen. Okay, let's do example 7 here, if there are no questions. The distance S in feet, okay, a moving car from a stoplight, okay, is given by the function, okay, name please?
Shayla.
Shayla?
Shayla.
Okay. Sadler? Is that what you, no.
Collier.
Oh, I'm sorry. First name.
Shayla.
Let me find it. What's the last name?
Collier.
Collier. There. Oh, Jayla. Oh, I'm sorry. Your hair's changed and you threw me off. Okay, sorry about that. Anyone else come in since I called roll? I'm sorry? I can't hear you.
Did you mark Sadler here?
I don't think so. Let me see. Yeah, I got you.
Okay.
Yeah, sorry. I thought she said Sadler. And I thought, but, okay. Sorry about that. My hearing is terrible. Okay. So, this distance in feet a moving car is from a stoplight is given by the function. Now that's a strange sounding statement. The distance a moving car is from a stoplight. Okay. This is saying you're at the light and then it turns green. So it's no longer a stoplight. It's now a green. And now you start leaving. So the distance you are from that light, that's what it's talking about. And here is that function, S of t, as a function of time, is equal to 20 t to the 3/2 power. Whoa! What in the world do we mean by 3/2 power? Anyone recall?
Square root.
Second?
Square root.
Okay, that's what the 2 in the denominator means. That's the index of a radical. And if you don't see an index, you understand it to be a square root. So it's the square root of what?
T.
Not just t.
Right.
T cubed. Okay, so the numerator is the power that you raise it to. The denominator is the index of the radical. So this is square root of t cubed. Or, this can be written two different ways. The square root of t cubed or the square root of t cubed. Either way, you can do the cubing inside the radical or outside the radical. Either way, it gives the same answer. Okay? Most of the time, if it does have, if t cubed does have a, well, if t has a square root, then it's usually easier to take the square root first and then cube it. All right. Remind me? Amina, got it. Good deal. Okay. Anyone else come in since I called roll? Okay. So that's what we mean. Now, was I right? Is this from stop, how far did you go? Or is this when you're approaching a stoplight, how far are you from it? Which would this be? That's what I had to check to see which way. Can you tell from that equation which way it is? Think of t equals 0. What's your distance? 0. So this must mean you're at the light, it turns green, then you go. Please don't go while it's still red. Okay. So you go then. So this is the distance from a stop, that you're going for it. Okay, where t is the time in seconds. So s is in feet and t is in seconds. Okay. Okay. Find the average speed of the car. So we want average speed of car, okay, from t equal 1, t sub 1 equals 0, so that's from stop, to t2 equal 4 seconds, okay, and then we'll do another one, t1 equal 4 seconds, to t2 equal 9 seconds. Okay? Now, how do we do average rate of change? That's what this is. Average speed of the car, average rate of change. How do we do that? Anyone remember? I know it was a long time ago. Okay? What's average rate of speed? Change. All right. Carla?
Yes.
Yeah. Goodness, I'm hot in here. There we go. Good deal. All right, anyone else come in since I called roll? Okay, anyone recall what average rate of change is? Looks a lot like a couple of other things we've done. It's what? Yeah. Okay, we're going to call it T2 minus alpha of, let's just not call it F, let's call it S. Okay, S of T1 over T2 minus T1. Yeah. Change of y over change of x. Change of distance over change of time. Change of speed. Average rate speed of the car. Okay? So, what's your displacement at T2? Which is 4 seconds. Okay? So the first will be S of 4 seconds minus S of 0 seconds divided by 4 minus 0. I can do the denominator. What's S of 4? Anyone get that for me? S of 4. Someone can tell me the first number, right? $20. Okay. Times 4 to the,
Cube.
okay, 4 cubed, but I want to do the square root first and then cube the square root, because I'm lazy and the numbers are smaller this way. Okay, so this would be 20
8.
times, yes, 8. Square root of 4 is 2. 2 cubed is 8. And 20 times 8 is 160. And what would that be measured in? Feet. Because S is measured in feet. Okay? So there's your numerator, the first one. 160 feet minus, what is it? 0. S is 0. That's 0, because 0 cubed is 0. 0 square root of 0 is 0. It doesn't matter which order you do it. 20 times 0 is 0. So this is minus 0. I think I can even do that one. Feet, because you're at stop. And 4 minus 0 is 4. So we can just leave off that. What is and this is seconds, by the way. And what is your average rate of, your average speed? 40. 40 what? There's units involved. Feet per second. Perfect. Okay. Let me get your name, please. Alana. Okay. There you are. Good deal. Anyone else come in since I called roll? Okay. 40 feet per second. So that's the average rate of speed. Okay, average speed from t equal 1 to 4 seconds. Let's do the same thing from t equal 9 to 4 seconds. 4 to 9 seconds, sorry. So what I'm going to do here, because I don't have much room, I'm going to erase, and one thing I'm going to erase is this ugly F that was stuck in there. Okay. And we're going to change this to 9, that to 4, that to 9, that to 4, and we have to recompute that, and that, and that, and that. Okay. And why don't we recompute? We're going to leave that one alone. Okay. So what are we going to need first here? T2 in this case is 9. So we need to do S of 9. This will be in seconds. Goodness gracious, it's hot in here. That will be 20 times, and which way you want to do this? Anybody? Plugging in a 9 here. What would that be?
3.
Square root of 9 cubed. That would be 20 times, what's the square root of 9?
3.
3 cubed is 27. 20 times 27, I believe is about 540 feet, right? So this will be 9 seconds minus S of 4 seconds. That'll be 9 minus 4 seconds. And we just calculated S of 9 to be 540 feet. And we had already calculated S of 4, which is 160 feet, right? And then what's 9 minus 4? 5 seconds in the denominator. Okay? Take a little bit of effort here, not a lot. That would be 380 feet divided by 5 seconds. And that would be 76, is that right? Feet per second. Okay. Does that make sense? Let's see how the book did. Oh, wow, they got it right. Good for them. 40 feet per second in the first 4 seconds, 76 feet per second. Can I get your... Huh? Mayfield, got it. Keandre, all right. Okay, good. Good attending today. All right. All right. Any questions on that? Do you see how it works? Okay, any questions? All right. Average rate of change, change of y over change of x. Okay, only here, change of s over change of t. Okay, you have to calculate the s from the function they gave you, and the t is just a plain subtraction. Change of t is a plain subtraction due to math. All right. No questions? Oh, there is a checkpoint, bottom of the page. Please try to do those soon after class. And if you can't remember how we did it, audio video solution at larsonprecalculus.com. An absolutely free website. And by the way, I meant to say this earlier. I hope all of you saw the email and the announcement that they finally sent me a code. Okay? What do they call it? WebAssign code. Now, for those who haven't seen it yet, here's what it is. Lawson.al space 2268 space 1501. Okay. Now, at least one person has already stopped and told me that the code works, but the one from her receipt didn't work. Okay. I don't know what to do about the receipt code. Do they give you any help number if you're having trouble or something like that? They do? Okay. There's another thing you can do is go to that help number. Where do you get that or find it? It's on the receipt? Okay. If the bookstore can't help, then try that number. What's the other thing? Go to Cengage. Okay. Oh, and do help there. It's their problem, I think. Check the bookstore first just to see if they can help. Then after that. Yeah. What's that?
She'll have to call WebAssign because Lawson, the bookstore, they don't have anything to do.
Okay. They just take your money, huh? Okay.
And if there's something wrong with it, they'll have to send her something.
Right. Well, frankly, because I'm sort of a squeaky wheel type person, I would still like to complain to the bookstore, and if they get enough complaints, then they can, Cengage will start hearing from them, okay? So I still say, be a squeaky wheel, all right. Q came in. Anyone else come in since the called roll? Okay. Have any of the rest of you had problems logging in or anything else? Okay. All right. You do need two things. One is the number they give you on your receipt. They say, don't throw that away. And then you also need the number I gave you.
Do you need to purchase this?
What's this?
Is it for like practice?
Yeah. A WebAssign.
Or is it for like...
Okay. When they first came out with this, they said you had to be on WebAssign before you could access your ebook. I think this term they modified that a little bit and maybe gave you a grace period or something. And you might have been able to access it even without this. But I think the grace period may be coming to a close. So if you do have trouble accessing your ebook or anything else, you can use this. The other thing is WebAssign does have helpful stuff in it. Okay? You don't have to do it. I'm not making any assignments in it, but it gives you great practice and it has good tutorial help. At least that's what they say. Yes? Say this again?
If I purchased it before a long time ago, like I can simply put that code in and pull that stuff.
You purchased it?
No, I had the WebAssign thing.
Okay.
You got
Okay. If it was a previous class, that
Yeah,
one.
it's my password.
just try to put in the code. Just try
Okay.
to put in that code.
Yeah.
Make it work.
Yeah. I'm sorry about this. I probably should know more, but I know almost nothing about the way Cengage operates. And I'm kind of glad because I'm afraid if I understood it, that would say something about my mental state. I don't know. I don't know. But if there's some way I can help, I'll try to help. But I think the best idea is to go to them and get help from them because they know the convoluted way they put the system together, and I sure don't. Okay. So there is your number. Anyone who didn't see the email or the announcement, there it is, written in ugly. Okay, never mind. Okay. All right. Good deal. Any questions on this problem or other questions? All right. Let's move on to even and odd functions. Probably some of you thought a lot of these functions are sort of odd, didn't you? No, I didn't say that. What do we mean by even and odd functions? And they're really leaving out a huge classification here, but we'll get to that in a second. You've studied different types of symmetry. Yeah, I know you've studied symmetry of a graph. In terminology of functions, a function is said to be even when the graph is symmetric with respect to the y-axis. It's said to be odd when it's symmetric with respect to the origin. Okay? Now, what do we mean by respect to the origin? With respect to the y-axis, that sort of makes sense. What it does on this side, it does exactly the same thing on that side. What does it mean with respect to the origin? It means that Jimena is here. Okay? All right. Did I pronounce it right that time?
Yes.
I've been practicing all the time you weren't here. Okay. So, okay. But now I can't. There you are. You are here. Okay. All right. Anyone else come in since I called roll? So, even when it's symmetric about the y-axis, odd when it's symmetric about the origin. Whatever it does on one side of the origin, it does the opposite on the other side. Okay? The symmetry test, from my arm waving here, which people at home can't see, by the way, the symmetry test yields the following test for even and odd functions. So here's all you have to remember on even and oddness. If you have a function y is equal to f of x, that function is even when for every x in the domain of the function, you put in, instead of x, put in a minus x and figure out what f of minus x is. If you wind up getting the same thing as you did from f of x, that means what you do over here, same thing happens over here. Doesn't change these values at all. That means it's even. However, a function is odd, y is equal to f of x is odd, when for every x in that domain, if you put in that same minus x here, you get exactly the opposite of this one. Not just something different, exactly the opposite. So that means if it's doing this on this side, it's doing that on that side. If it's doing this on doing that on that side. Not even, odd. Okay. And guess what they left out? The biggest class. The neither class, okay? Because it may be that you put in, and notice the test. The test is the same for either one. Put a minus x in for x, see what you get. If you get the same thing, it's even. Exactly the opposite, it's odd. If you get neither the same or the opposite, it's a neither. Okay? Now, when you get into trigonometry, and I hope most of you will continue there, most of the trig functions are either even or odd. But most everyday functions that we'll run into in this course are going to be neither. Okay? Though there will be even and odd ones there as well. All right, so here's one. Here's a function. G of x is equal to x cubed minus x. And they tell you the answer. I really, it just aggravates me no end. Pretend you can't see any of this. Okay. All right. It's not there. Okay. Now, what's the test? G of negative x. So what do you do here besides these? Thank you. Are y'all awake yet? Okay, good. All right. So, what do you get if you plug in a negative x? Negative x cubed, that's the negative x in parentheses, cubed, minus a minus x. Well, what's negative x cubed? It's negative x cubed, okay? Almost redundant, isn't it? Because you do a negative x times negative x, you get a positive x squared, but then multiply it by another negative x, you get a negative x cubed, right? And then when you do minus times minus, you get plus x. Now, how does this compare to that? How does this right here? Say again? Exactly the opposite. This one's positive, that was negative, this was negative, that was positive. Exactly the opposite. That means it's what? Odd, yes. You thought it was fairly odd, didn't you? Okay. Okay, so it is odd. Okay? Now, I think they're also going to do something else for you. Oh yeah, they plug it in and don't show you how they do it, but, well, they did too. I'm sorry. All right. They plugged it in and did exactly like we did and got negative x cubed plus x. And then noted that's exactly the opposite, the negative of this one. Okay, because negative x cubed, positive x. Yes, exactly the opposite. Okay? And that's negative g of x. All right. It passed the test for an odd function, so it is odd. Now, they're going, whoa, no they didn't. Thought for sure they're going to graph it for you. In the book, they did graph it for you. I don't know why they didn't on the slide, but they didn't. Okay? And for those who don't have books or don't have your ebook open, this is how it looks. And you see whatever it's doing here, it's doing exactly the opposite on the other side. When it's going up, it's going down. When it's humping up, humping down. Okay. See exactly the opposite. Okay? So that's an odd function. Okay. Now, this next statement works for polynomials. I don't want to say polynomials only, but it does work for polynomials. What do you notice about the exponent here? 3. How about the exponent here? 1. What do you notice about 1 and 3? They're both odd numbers. Oh, isn't that a coincidence? Okay. So, if you have a polynomial function and all of your exponents are odd, you know it's an odd function. Okay? Now, you can't read that. Okay. All right. Here's a function, h of x. X squared plus 1. What's the test? What is the test? Put in a negative x and see what comes out. And what do you get here? Negative x squared plus 1. And what's negative x squared? Positive x squared plus 1. Guess what you get? The same thing you had before. That tells you this function is even. Okay? Now let's see if my little rule works here. What's the exponent here? 2. What's the exponent here? Exponent.
0.
X to the, what did you say? 0. Because x to the 0 is 1. Okay? So you don't see an x, that means it's x to the 0th power. Okay? Now, both of those are even. It's a polynomial function, so sure enough, that little trick will work here. Okay. Now I can erase what I smudged out, really effectively, by the way. Okay. And you see it is even because h of minus x is h of x. Here's h of minus x, negative x squared plus 1. That would be x squared plus 1, exactly the same as h of x. Passes the test for an even function. All right. Now, let's see how it looks on a graph. Oh! All right. Here's the y-axis. Notice exactly what's happening on the right is the same as what's happening on the left. Just a mirror image across the y-axis. This is a mirror image across the origin. Put a mirror up here, and the same thing happening here. It's a counter. Okay. They actually draw in the line y is equal to x, and that's what's mirrored across also. You look at it either way for an odd function. Okay. Now, oh, here are the graphs. I didn't have to hold up my book. I was hoping they would. This is the odd function. What's happening over here? The same thing happens here, but in the opposite direction. Goes up here, down here. Down here, up here. Okay? Any value x, y here, minus x minus y will be down there. Okay? Odd. Over here, exactly the same on both sides of the y-axis, mirrored across the y-axis. If you have an xy here, have a minus x, you have the same y here. So the same thing's happening on either side to the y. Now, any questions on that? Now this time, I want to let's do the checkpoints in class, okay? And I'm not going to draw them for you, and you don't even have to do the other. But just a little rule I gave you, what do you think about A? Now some of you may not have your book, so let me write A down. F of x is equal to 5 minus 3x. So 3x. What is it? What you say? It's a what? Just looking at it, what would you think? Okay, think odd, because this is 1. What's your exponent here? 0. Zero's even, 1's odd. This is a neither. You're absolutely right. The B one here, g of x is equal. Now this only works for polynomial functions. Don't try it on others. You have to do the test on others. But here's one, x to the 4th minus x squared minus 1. What's that going to be?
Even.
Okay. You mean what? Even. Okay, it's sort of like, do you want apples or oranges? Yes? Okay. Yeah, okay. Didn't see the fit. Did you, when you were young, did you walk to school or carry your lunch? Okay, never mind. Okay. Okay. Yeah. Even. 4 to 0. Yeah. Okay. And let's do this one. H of x, and this only works for polynomials, so don't try it on others. 2x cubed plus 3x. Odd, absolutely, because both exponents are odd. Do the test, you'll see they work. This is a shortcut that you can do only for polynomial functions. I don't want to say only, but you always can do it for polynomial. Do you? Anyone need that a little longer? Sorry. Okay, for some reason my nose has started running. I'm not about to leave class and go catch it. Okay. All right. Everybody got it? All right, that does finish 1.5. Finally. Okay. So let's move on to, it's hot in here, 1.6. Okay. Oh, what am I doing? Got to give you homework exercises. Forgive me. Okay. All right, please. Let's first do the vocabulary, top of page 56. The blank, blank, blank is used to determine whether a graph represents a y as a function of x. Think graph. How do you tell if a graph of a function is a function or not? Vertical line test. Excellent. Number 2, the blank of a function, y is equal to f of x, are the values of x for which f of x equals 0. The zeros of the function. Perfect. Number 3, a function f is blank on an interval when for any x1 and x2 on the interval such that x1 is less than x2, that implies that f of x1 is greater than f of x2. A function is blank when that's the case. X1's down here, x2 over here, but x1 is here and x2, f of x1 is here, f of x2 is there. Wait, I said it backwards, didn't I? No, f of x1 is here and f of x2 is here, sorry. It's a decreasing function, perfect. Okay, number 4. A function value f of a is a relative blank of f when there exists on an interval x1 to x2 that contains a, okay, such that x1's less than x2, so x1's here, x2 here, implies that f of a is always greater than or equal to the rest of your f of x's. Greater than. Maximum, okay, 2 choices, yeah, good, okay, good deal. Number 5, the blank, 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 4 blanks, between any 2 points, x1, f of x1, x2, f of x2, is the slope of the line through the 2 points. I think I heard it. What did you say? The blank, 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 blank? Average rate of change. And the line is called the, okay, the line itself is called the average rate of change is the slope. The line itself is called the secant, yeah, secant line. Oh, I couldn't hear. Secant line. Perfect. Okay. Number 6. A function f is blank when, for each x in the domain of f, f of minus x is negative f of x. Very recent. When f of minus x is minus f of x. Boy, that function's odd, exactly. Very good. Okay, homework exercises. Whew. Do either 7 or 9. They're both at Calc Chat. 9's at Calc View. Do either 11 or 13. They're both at Calc Chat. 11's at Calc View. Do any of the odds 15 to 25. They're all at Calc Chat. 25's at Calc View. Do any of the odds 27 to 31. They should all be at Calc Chat. Do any of the odds 33 to 39. They're all at Calc Chat. 35's at Calc View. Do any of the odds 41 to 47, they're all at Calc Chat. Do any of the odds 49 to 53, they're all at Calc Chat. 51's at Calc View. Do any of the odds 55 to 59, they're all at Calc Chat. 57's at Calc View. Do either 61 or 63 or both, they're both at Calc Chat. 61's at Calc View. And then on word type problems, applied problems, 65, actually that's 65, it should be at Calc Chat. Physics type problems, that would be 67 or 69, they should be at Calc Chat. Even odd and neither problems, any of the odds 71 through 75, they should both be at, all be at Calc Chat. 71's at Calc View. Now notice one of those is a polynomial, the other two aren't. So you have to actually do the test for you can do them for all three, but you have to for the other two. And then any of the odds 77 through 81, they're all at Calc Chat. Do 83, it should be at Calc Chat. 85 should be at Calc Chat. 87 is one of those error analyses I really don't care for too much, but you can learn something through it. But just remember, they're giving you something wrong. You have to figure out what's wrong. All right? I don't like them to give you something wrong. I want you to see right stuff. 89 is something else you can do. That's Calc Chat. There's 2 true false, 91 and 93. You can do those. You won't see many of those on the test, but you can think through those. 95 should be at Calc Chat. You can think about doing that one. 97 is a writing problem. You can at least think through that. I don't know if those are at Calc Chat or not. And 99 is another even, odd, or neither problem, and that should be at Calc Chat. Any questions? All right.
What page is that?
That starts on page 56, 57, 58, and 59. Okay. All right. Ready for 1.6. Are y'all hot? It's just because I'm moving around and talking so much. It is hot. Okay. Okay. All right. Continuing chapter 1, functions and their graphs. Now we're going to go to the library. No, we're going library of parent functions. Oh boy, you thought you were away from them, weren't you? No, they're still looking on. No, what do we mean by parent functions? Well, here's our objectives. We're going to identify and graph linear and squaring functions. 2 types of functions now. Then we'll identify and graph 3 other types: cubic, square root, and reciprocal functions. Then we'll identify and graph stepwise and other piecewise defined functions, and we'll recognize the graphs of these parent functions. Somewhere along the way, they'll tell you what they mean by that. So let's start with linear and squaring functions. Now, one of the goals of this text is to enable you to recognize when you see a graph, what's the the likelihood of that type of function that represents by that graph. Or on the other hand, you got a function, you know what kind it is, visualize what kind of graph is this going to be. So for instance, you know that the graph of a linear function is this. The graph of a linear function, here is the linear function. F of x equal ax plus b. How do we know, besides they told us, that that is a linear function? Just looking at the function. F of x equal ax plus b. How do you know that's a linear function? Just by looking at it.
The degree,
Second?
like the degree is 1.
Yes, the only exponent in the problem is a 1. X is raised to the first power only. If that was a fractional power, not linear. If it's a power greater than 1, not linear. If it's a negative exponent, not linear. Only exponent for the variable can be a 1. Okay? Now, why did they choose these letters A and B? I mean, they just represent numbers. What do they represent?
Slope and
Yes, the slope is the A part, and the y-intercept is the B part, which they just told you. Okay? Good reading. Okay, never mind. All right. Anytime you see a function that looks like that, that's a linear function. Okay? That has a slope. Could be a negative slope, positive slope, a zero slope, and it intersects the y-axis somewhere at B. Okay? Now, what can we say about the graph of a linear function? Here are some of the characteristics. What do you reckon the domain of that function will be? All real numbers. Exactly. Because it goes, whether it's going up or down, slope it any way, any value you put in will work. Domain is a set of all real numbers. How about the range of that function? All real numbers. As long as m is not equal to 0. What if m is equal to 0? What do we have? Slope of 0, which means? Second?
vertical.
Nope, vertical is undefined. 0 is? Okay, this is positive, this is negative. What would 0 be? Ah! Flat. Flat line. Okay. That would be m is 0. 0 slope. In that case, the range of the function, if m is equal to 0, is only that value. By the way, if m is equal to 0, let's back up a slide here. That's your m. If that's 0, what's your function? F of x equal b, a constant. And that's what we call it, a constant function. The b could have been 3, it could have been minus 45, it could have been pi thirds, it could have been anything, but it's always that value, 0 slope. Then the range would be only that value b. That would be the only output for that ever. Okay? Now, this is a little strange. We know this part, the y-intercept's got to be 0b, right? mx plus b. We know that. The x-intercept, on the other hand, is that strange thing. Now, where did that come from? Well, let's go back to this again. If y, whoa, let me get my pen color back. Okay, is equal to mx plus b, right? Now, what is true about a x-intercept? What's true about an x-intercept? Where the function intersects the x-axis. What's true about every point on the x-axis? Okay, every point in space or on a plane has 2 coordinates. What's true about every point on the x-axis? Y is 0, exactly. So if y is 0, we put in a 0 here. It's equal to mx plus b. Well, what's the x value then? Solve for x. What would you do? So subtract b from both sides, right? That gives you mx is equal to minus b. And then what if you're solving for x? Divide by m. Now, we've already said m is not 0, okay, so that makes this legal. So what's your x-intercept? Minus b over m, okay, which is exactly what they said here, minus b over m when y is 0. Now, I don't memorize that. I don't ever even put that in my memory bank, okay? It's easy enough to calculate. Now, what can you say about the increasing, decreasing nature of that function? Anything? When is the function increasing? When what's true? He's looking strange. That's what's true. No. What's true? What's true about your slope? It's positive. This is an increasing function. If the slope is negative, it's a decreasing function. If the slope is 0, it's a constant function. Okay, you already know lots of stuff about the slope. The graph is increasing when m is positive, and all doesn't change. Okay, decreasing when m is negative, and it doesn't change, or is constant when m is 0. Okay, so we know those 3 things are 4 things about linear functions. Okay, now, write a linear function f for which f of 1 is equal to 3 and f of 4 is equal to 0. What in the world does that gibberish mean? What does this represent? That statement, f of 1 is equal to 3.
Is y equal to 3?
Second? You may have said it right. I can't hear.
Is y equal to 3?
Y, y is equal to 3? Is that what you said? Perfect. And what's x? 1. Yeah, this is the x goes here, the y goes there. That's it, exactly. This represents a point 1, 3. Okay? What does this represent?
4, 0.
A point 4, 0. If you know 2 points, can you write me a function for that? How?
Plug it in the slope.
Plug it into what? Second?
What is called intercept slope?
Second? Yes. Okay. Okay, you're saying the slope-intercept form, which would be, is this what you mean? F of x equal mx plus b? Is that what you meant?
No.
No, you didn't. Okay, what did you mean?
The other one.
Which one? Tell me.
It's like y2 plus
y2 minus y1. Second? Over x2 minus x1. What's that equal? Yes, exactly. You don't get the equation for the function here, but you get what you need to get the equation for the function. This is the formula for your slope. Okay? So what do you put where? You tell me. 0 where? Top there? Okay. Next? Minus 3 over 4 minus 1. Now, how did you know that this wasn't your 2 and that 1? It doesn't matter. You're going to get the same answer either way. It really doesn't matter. But what does matter, whatever you choose for that y2 determines everything else. If you choose that, that means this has to be the y1, this has to be the x2, that has to be the x1. Once you choose that first y, everything else is fixed by your choice right there. But it doesn't matter which one you choose to be. Okay. So what does this give you? Slope is negative what? Negative 3 over 3, which is negative 1. There you have the slope. Okay? It still doesn't give you a linear function. You have the m now. We can put that in. F of x is equal to minus x plus b. But I still don't know what the b is. Okay? Now, I thought maybe this would be it, but that's the x-intercept, not the y-intercept. Okay? How do we get it? Okay? They've given you 2 f's here. Pick one. First or second? Pick one. First? Is that what you said? Okay, first. Okay. F of 1, let's write this down. F of 1 is equal to minus x plus b. But we also know that f of 1 is equal to 3. Well, if f of 1, I should have done this, f of 1 is equal to minus 1, I'm plugging in x equal 1, plus b is equal to 3, right? I think I can solve that for b. How? Add 1 to both sides, and what do you get? B is equal to 4. Now we go back and say f of x is equal to minus x plus 4. There it is. Let's just check and make sure both of these things work. When you put in a 1 for that, minus 1 plus 3, I mean, minus 1 plus 4 is equal to 3. Yes, it is. And when you plug in the 4, minus 4 plus 4 is equal to 0. Perfect. So both of those points are, this is the function that represented by that function. Right? All right. Now that's one way you can do it. There are other ways you can do. Thought maybe you were talking about the, once you got the slope, then you can change this a little bit and do y minus y1 is equal to m times x minus x1. That's called the point slope formula. That would work too, and that works just as well as the way we did it. Either one works.
I have a question.
Yes.
So, you lost me at B. Like, how did you get B?
How do you get b?
Did you just pick?
Okay. You pick either one of those. Well, you first write down, you found out m. M was minus 1. You write that down. So now this is your function, except we don't know what b is.
So you just plug it in?
So pick one of those 2 points. This is just one way to do it. One of those 2 points, I'll pick the first one. F of 1, you know, is equal to 3, and that's equal to minus 1. The x is 1 plus b. I sort of did it. That's what this is. F of 1 is 3. That's equal to 3, and that's minus 1 plus b. Solve for b. So that's how you find it. Okay. Good deal. Any others? Any other questions? Great questions, by the way. Okay. Let's see how they did it. Goodness, I'm hot. Okay. To find the equation of a line that passes through these 2 points, and that's exactly what y'all noted. That represents a point, this represents a point. This is 1, 3, this is 4, 0. Okay? First find the slope, exactly what you suggested, and plug it in. They even plugged it in the same way, but it really didn't matter. If you had chosen the other to be your 2, this would have been 3 minus 0, which would be 3. This would be 1 minus 4, which would be minus 3. And 3 over minus 3 is still minus 1. So it doesn't matter your choice there. Once you choose that first value, all the others have to fall into place. So that gave you a slope of minus 1. Minus 3 over 3, which is minus 1. All right, now let's see how they proceed. They go to the point slope formula. Now, you might say, do I have to memorize another formula? No. If you look at this formula, y2 minus y1 is equal to over x2 minus x1 is equal to m. Y'all knew that one, right? You told me that one. Now, here's what I'm going to do. It's magic. This is if you don't know if you know the points but don't know the slope, this is what you use. The m is unknown. Once you calculate the slope and know what slope is, then lose one of the points. Preferably that one. Now, y and x are variables, no longer things. You still have one of them, x1, y1, and you have the slope that you already know, and then guess what you do? You just multiply both sides of this by x minus x1. Because we really don't like denominators, do they? They represent fractions, right? Okay, so multiply both sides by x minus x1. Over here, they go away, and that gives you exactly that formula right there. Y minus y1 times the x minus x1 is over here is equal to m times x minus x1. Then you just plug in 1 point. Y'all chose the 1, 3, right? Let's see which one they chose. Does it matter? Ah, they chose the same one. Too bad. So they chose 3 for y1, so that would be y minus 3 equal to m, which is minus 1. You already calculated x minus 1, because the x1 was 1, minus 9 is already there. So, do the math. Y minus 3 is equal to minus x plus 1, right? Yes?
Yes.
Okay. So, minus 3, y minus 3 is equal to minus 1 plus 1. They skipped a bunch of steps. Add 3 to both sides, and 3 plus 1 is 4. Y is equal to minus x plus 4. But that depended on picking the right point, right? No, it didn't. You could have chosen the other point. Y minus, what was the other one? 0 is equal to minus 1 times x minus 4, right? This one's even easier. Y is equal to minus x plus 4. You get the same answer no matter which point you pick. Okay? You better, okay, if you did it right. So it doesn't matter which point. Either one would work. And we got the same answer as we did with our little way, right? Okay. One last step they did, they wrote it in function notation, which frankly, I was writing in function notation the whole time. Alpha of x equal minus x plus 4. Why is this true? Why can you go from this step to this step? What's always true? Y is equal to f of x. Okay. Just change the y to f of x. Perfect. Remember that. You got most of this course not. And here's a graph of it. What can you tell me characteristics of that graph?
It's linear.
It's what?
It's negative.
Okay, negative slope, meaning it's a decreasing function. Okay, very good. Even or odd?
Odd.
That means that what it's doing over here, it does the opposite over here.
Oh, it's neither.
Neither! Okay. This is 1, that's a 0. No, this is the neither. Okay. X-intercept. 4, 0. Y-intercept?
0, 4.
0, 4. Perfect. Okay. Good deal. Two special types of linear functions. We've already mentioned one of these, the constant function. If that m is 0, the slope is 0, doesn't go up or down, it's one value forever, okay? That's f of x equals c, okay? You get that? And here, what's the domain? All real numbers. What's the range? C. It's the only number you can get, C. The only y value is C, ever. So here the range is a single number, C. There's the graph. What's the x-intercept? X-intercept? There is not one, okay? Unless, of course, C was 0, then every point's the x-intercept. What's the y-intercept?
Something. It's 0.6.
0, C. Because that's the only value y will ever take on. So your first answer was right for the second question. Okay. All right. C is your y-intercept. Okay. Even or odd? Say again? Neither. Okay. It's what? Even. Yeah. What is happening over here? Happens here. Happens everywhere. Okay. So that's an even function. Because the exponent for x here is 0. There is no other, so that is even. Okay? Horizontal line, blah, blah. Domain? All real numbers, range? C. That constant C. Okay. C is yes in Spanish, by the way. Okay, never mind. All right, sorry. Okay. Okay, we just said all this. Domain and range, wait. All right, I'm sorry. Sorry. The graph of a constant function of a horizontal line shown here. Now, this should have been a new sentence on the next page. The identity function has the form alpha of x equal x. Now, why do you think that's an identity function?
Because it's the same.
X and y are the same. They're identically the same. Because what's y? F of x, so y is equal to x. They're always the same value. If x is 17, y is 17. If x is minus 43, y is minus 43. If x is 0, y is 0. Now, how do you think that's going to look on a graph? How will that look on a graph? This one. I'll purposely not change the slide. What will this one look like?
It's gonna be linear though.
It's going to be what?
It's gonna be
Vertical? Okay. Not horizontal either? Okay. Here's the function. Can you tell me the slope?
1.
1. Is that positive or negative? Positive, okay. What's the y-intercept?
0.
0. So guess what? It's going through the origin, y-intercept, and the slope is 1. There it is. See it? Slope of 1. And for instance, when x is 1, y is 1. When x is 2, y is 2. When x is negative 1, y is negative 1. When x is negative 2, y is negative 2. Identity function. Okay? Domain. All real numbers. Range. All real numbers. Okay? Increasing, decreasing. Increasing. Even or odd. Or neither. Say again?
Even. It's odd.
It's odd because whatever you go up here, you do the opposite down here, right? So it's odd. Alpha of negative x is equal to negative f of x. Okay. All right. 2 special cases of linear functions. In general, a linear function is going to be neither even nor odd unless it crosses through the origin, then it will be odd. If it's constant function, it'll be even. Okay. All right. Are we running out of time? Oh, we can't be, can we?
4 minutes.
4 minutes.
4 minutes.
All right. Let's at least start thinking of what the squaring function looks like. Here's the squaring function. Take your x and square it. Okay, that's why it's called the squaring function. Okay? Now, what does that look like as a graph?
Gravel.
You're absolutely right. They call it a U-shaped curve. I really don't like U. The reason I like U. Okay, no. The reason they call it U-shaped is always rounded at the bottom, not V, but U. The problem with calling it U-shaped, U goes straight up. These don't. These always are increasing like this. So it's a parabola shape. No, okay. Following characteristic. Guess what its domain is? All real numbers. How about the range? What's the range? When you square, what do you always get? Positive. You take a negative number, square it. Positive. The positive number, square it. Positive. 0, you get 0. So you never get a negative number. So the range of this are values greater than or equal to 0. Non-negative is actually the better way to say it. Greater than or equal to 0. Okay? Even or odd? Neither? What you think?
I think it's even.
Even, because it does the same thing on both sides. Exactly. And the only exponent is a 2. Right. Does it have an x-intercept? What is it?
Yes.
Say again?
Yes. Yes.
Okay, and what is it? The x-intercept. Where does it intersect the y-axis?
Possibly 0.
0, 0. That's also the y-intercept is 0, 0. Both of them intercepts are at 0, 0. The only intercept at 0, 0. Okay, how are we doing? Okay, we'll start with the second page next time. Let me give you maybe just a few homework exercises. You can do either 11 or 13. They're both at Calc Chat. 11's at Calc View. And you can do 15. We haven't done the rest of them. So 11 or 13 and 15. And 15's at Calc Chat. All right. We'll pick up then next time with the second half of this thing, and this begins.
So on the website, do we have to do the assignment?
Sorry?
On the website, do we have to do the assignment?
No, that's completely, those are for your practice only.
Okay, so we just need it just for the book.
I think so, yeah. They say you have to have it, so.
So you still gonna give us like the quizzes in class?
Yeah, in fact, I'll give you the quiz next time. Yeah.
Okay.
Yeah.
The website code, are we supposed to do those problems?
It's up to you. If you need more exercise and practice, they have a tutorial help. Yeah.
So do I need to buy a book for this?
You don't have to, that's up to you. Yeah. Whether you think it's helpful or not. Okay.
So remember I told that I cannot get access to ebook although I pay 6 days unlimited.
Did you, excuse me, Browski. Okay, see you just a second. Yeah. I forgot your first name, sorry.
So I told bookstore and they said to talk with you. but-
Okay.
So I will contact.
Did you do Cengage Unlimited? Okay, you should be able to get it between the code that came on your receipt, if you kept your receipt, and the code I put up here and sent you an email. Yeah, you should be able to get it. If not, then contact Cengage. Or
Okay,
complain to the
and-
bookstore.
And for this you need research paper. I already submitted it to you.
I know, I've already
And-
created it and put it on Blackboard.
And what you all need, like test, chapter
quizzes,
test,
right.
and quizzes.
Yeah, I'll give you a quiz next time.
Okay, like
Hard
take
quiz.
home.
Yeah, take home quiz.
And
Test won't be take home, but yeah.
test is on the final day.
No, there'll be tests after each chapter. After 1.59, we'll have a test.
And that is like in class?
In class, yeah.
Okay.
Yeah, yeah,
Thank you, sir.
okay. Yeah, I already talked with you, yeah.
Yeah, who did you say talk to?
Go to the cashier's window and see if they can help. You know where that is, right by the bookstore? Okay, that's what that'd be where I would suggest go first. Okay. Yeah, your name was not on the roll when I went to do the no-shows. And I don't know why. You've been here every day. So check with the cashier's window and see why your name wasn't showing up on the roll. Okay, great. Sorry to pull you out, yeah.